Hey there, Reumen. This is, Jay. I'm used to saying Mr. Lawrence because I'm used to making these videos for my students. But this is that video I told you I would make. You can watch with your mom. And I'm just going to go over a couple of things we went over just to help reinforce them. And if you like this, then maybe I can do this for you a little bit more often. But anyway, I've got this, I call it a double distributing problem. You have a binomial times a binomial, or a quantity times a quantity. Now, if you like, you can pause the video and try the problem on your own and then see what happens. Now, I did things a little different. There's actually two of these problems. There's one down there as well, which we're not ready for yet. But I wrote them out of order just to see if I could fool you. Not that I want to trick you, but so that you recognize it can happen lots of different ways. So anyway, if you want to pause it, go right ahead, try this on your own. And if you're ready to see my solution, that's okay too. All right, so remember, I'm going to take this 5, this first number in this quantity, and I'm going to multiply it by the second quantity. So I'm going to go 5 times the quantity of 3 minus 2x. And then I take this plus 3x here, and I multiply it by the same quantity, 3 minus 2x. And now I distribute, right? 5 times 3 is 15. 5 times a negative 2x is a negative 10x. Let's see over here. I've got 3 times 3, which is 9, right? Feeling like I've made some kind of mistake, but I don't think I have. All right. Oh, there it is. I saw it. I caught it. Did you catch it, Reumen? There it is. I shouldn't write plus 3. I should be writing plus 3x. So sorry about that. Plus 3x. And so when I distribute that positive 3x, I won't get 9. I'll get 9x. And then I'm going to multiply 3x times negative 2x. So 3 times negative 2 is negative 6. And x times x is x squared. So now I'll combine my like terms. It looks like I have a negative 10 and a positive 9. So if the teacher's not expecting you to write it in any particular order, this would be a great answer. Negative 10 plus 9 would be a negative 1. And there you go. There are no other like terms. All right, here's this other one. Again, I've written it in a different order. Why don't you see if you can do it on your own? Unpause the video. All right, here comes my solution. I'm going to do 6 times that quantity. So I'm going to go 6 times quantity of x plus 8. And then I'm going to take the negative x and multiply it by the quantity of x plus 8. And then I'm going to distribute. 6 times x will be 6x. 6 times 8 will be a positive 48. And then I'm going to distribute a negative x. Remember, x times x is x squared, so I'm going to have a negative x squared. And then negative x times 8 will be a negative 8x. Now, you're used to the like terms being in the middle of the problem, but however, in this case, they're here. And notice that 8 is negative, very important. So I'm going to combine the 6 and the negative 8 and get a negative 2x plus a 48 minus x squared. Now, I don't like the order this is in, but if they don't require you to do it in a specific way, this is perfectly acceptable. All right, so there's 2 of those problems. And then this problem, I think I only have 1 of these. You did pretty well with these. Remember, I'm going to rewrite this fraction. And I know you really seem drawn to the x's, so I'm going to do the x's. You seem 4, 5, right? It's all multiplication. Okay. And then your denominator, you have got 4 x's being multiplied, right? You just seem really drawn to doing the variables first, so I'm going to do that for you. So 4, 5, 6, 7. Oh, silly me, I wrote a 7. Sorry about that. You see, even math teachers make mistakes, silly mistakes too. We do it all the time. Everybody makes mistakes, and that's totally okay. By the way, those are my Z's. My first year as a student teacher, students didn't like my z's. They look like that. They said it looked like a 2, so they told me to put that bar on it, and I've done it ever since. All right, now the y's. Let's see. I got 1, 2, 3, 4, 5, 6, 7, 8. Okay. Then I need 9 z's, and it's kind of a pain to do it this way, but I'll go ahead and I'll just write them down here. Z, 1, 2, 3, 4, 5, 6, 7, 8, and finally 9. Now, I also want to rewrite the 12 as a 24 and 36. I know they have a common factor. Now, you were doing a good job down my basement the other day when you were rewriting them, you know, there's a big factor, and then looking to see if you could simplify them more. So I'm going to do it like you did. I'm going to pick, I think you'd probably definitely see a 4 goes in here. So I'm going to rewrite 24 as 4 times 6. And then I'm going to write 36 as 4 times 9. Okay, now we're going to do some canceling. The 4s will cancel. Let's see, 1, 2, 3, 4. Looks like there's just an x left in the numerator. Y's, 2, 3, 4, 5, 6, 7. Looks like there's just a y to the first power in the denominator. And then one of these z's and one of these z's. And there we go. So right now I'm going to have 6 in my numerator, 9 in my denominator. An x, see that x sitting there all by himself? A y in the denominator, yeah, there's that y. And then I'm going to have 1, 2, 3, 4, 5, 6, 7 z's all being multiplied. That'll be z to the 7th. There you go. Now, the 6/9 can be simplified. So I'm going to rewrite this as 6 as 2 times 3 times x, and 9 as 3 times 3 times y times z to the 7th. I'm not going to write out all those z's because they're not going to cancel each other out. There's nothing to cancel within the numerator. All right, these 3's can cancel. And so my simplified fraction will be 2x. 2 times x is 2x. And 3yz to the 7th power. There you go. Pretty easy stuff. Now, one suggestion I want to make. Instead of writing 24 as 4 times 6 and 36 as 4 times 9, if you get what's called the greatest common factor, sorry about that, I'm not sure why. I forgot to turn my email off. That's okay. Let me get rid of that. All right. If you think of the greatest common factor of 24 and 36, it'll be a lot easier to simplify. I'll be able to simplify in one step. So I'm going to think about 24 as 2 times 12, and 36 as 3 times 12. And you notice that the 12s will cancel and take me right to 2/3, which is what you have here. Okay, not wrong to do it the way you did it. Your way is a good strategy, especially if you don't see the GCF. But if you know to look for the GCF, it might get a little simpler. Hey, I'm going to wrap this video up now, Reumen. I enjoyed working with you. Again, you know, if you guys want to go a different route, that's totally fine with me. But if not, I'd love to help you out. All right, I will see you soon. Have a good night.